Hi, welcome back to Moose of Chemistry. This is Stoichiometry Introduction to Limited and Excessive Reactants. Alright, using our flow chart, my grams to my moles to their grams is what we're going to be using today. Alright, so let's look at our first problem. 2CuCl2 plus 4Ki yields 2Cui plus 4KCl plus I2. Alright, now, in problem A, given 0.56 grams of CuCl2 react with 0.64 grams of Ki, how many grams of I2 are formed? Alright, so what we're going to do is we got this reactant here, and we have this reactant here, and we have our masses of both our reactants. So we have to see which one produces the least amount. When we figure out the one that produces the least amount, that will be the amount of grams that are of I2 that can be formed. Okay, so let's go ahead and do it. So we go 0.56 grams of CuCl2 times 1 mole of CuCl2 divided by our molar mass of copper chloride, and so that'd be 134 grams, or 34.45 grams to be exact, of CuCl2. That 4, hang on for a second, let's get, that 1 4 doesn't look very good there. Let's get rid of that and make a better 4 there. Okay, so let's do that. Alright, now let's move on. Now we want to do the mole ratio. So we went from my grams to my moles. So we want to go from my moles to their moles. So we have to use a mole ratio. And we need to know the mole ratio between copper chloride and iodide. So it's a 2-to-1 ratio, right? So we've got 2 moles of copper chloride on the bottom to 1 mole of I2 on the top. But we don't want moles of I2, so we're going to go to their grams. Now that we have their moles, we're going to go to their grams. So we put 1 mole of I2 on the bottom here. And we're going to put the molar mass of I2. Now the molar mass of I2 is 2 I's, so it's going to be 253.8 grams of I2. So now we're going to go ahead and cancel out our common units just like this. And when we do the math, we find that to equal 0.53 grams of I2. Alright, so let's look at the other one. So we have 0.64 grams of Ki. That's our other reactant. And we're going to do the exact same thing that we did above with this problem. So now we're going to turn it into moles of Ki. So 1 mole of Ki over its molar mass, which happens to be 166 grams of Ki, times the mole ratio. What's the mole ratio between Ki and I? It's a 1-to-4 ratio, right? So we have 4 mole of Ki on the bottom and 1 mole of I2 on the top. Then we're going to convert that from their moles into their grams. So we're going to put 1 mole of I2 on the bottom, and then the 253 grams, 253.8 grams to be exact, of I2 on the top. So now we're going to cancel out our common units. And when we do that, we come up with 0.24. And let's fix that again. 4 didn't come out very well. All right, so let's do this. We'll put a 4 there. Grams of I2. This one is the less amount. So that tells me something really special. That tells me that my Ki right here on top is my limited reactant. So Ki is my limited reactant. So this is my limited reactant. And that makes CuCl2 my excessive reactant. See how that works? So what is the limited reactant? The limited reactant is Ki. Now, the last question says, how many grams of the excess is left over? Well, we're starting with exactly 0.64 grams. That's how many grams that we know that we have of Ki, right? That's our limited reactant. So we're going to use that one to work the problem, find the excessive reactant. So in the excessive reactant, we have 0.56 grams of CuCl2, right? So now let's go ahead and work this problem of our limited reactant. So we got Ki right here, 0.46 grams of Ki times 1 mole of Ki divided by the molar mass of Ki, which is, of course, 166 grams. Right? Times let's do the mole ratio between Ki and copper chloride. So copper chloride is 2 moles of copper chloride. Over 4 moles of Ki. And now we're going to put 1 mole of copper chloride on the bottom. So we want to change it into grams of copper chloride. And the molar mass of copper chloride is going to be 134.45 grams. So now we're going to do the math. And this is going to equal, so let me go ahead and check this out. This is going to equal 0.26 grams of copper chloride used. All right, now what we do is we take the 0.56 minus 0.26 grams, and what's left over is of our excess, still our excess amount, we have 0.30 grams of copper chloride left over. And that's it for this lesson, guys. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Moosing Chemistry!